Well, hi guys. I'm back. The radio is done. We got her all together, but we do have a problem, and I do know what's wrong with it. I've already troubleshooted it, but I thought, and I was going to fix it and then go from there, but then I thought, well, I'm supposed to be teaching, and this is a good opportunity to do some more troubleshooting. So here's what we've got. We'll turn it on, and let her warm up. Shouldn't take long. I just had it on just a little bit ago. Volume's wide open, and there is absolutely nothing. Zilch. Now I can tell you ahead of time, I've been through and checked the front end out, and it's fine. So it has nothing to do with the front end. We went clear through it, and what we're going to do right now is I've got the tracer up and running, and in fact it's actually picking up my audio generator. And since I already know that I do have signal up here, we'll come down through the circuitry on this switch, and right here is what comes out of the detector, and if we can get on that and see if we can pick up a signal, hopefully we can get on it and it'll stay, and see if we are picking anything up. And we have a signal.
This is a great exchange of tweets. I've never tweeted from a court.
Well, until the clip lead falls off. So we do have a signal there. So let's leave that alone, and let's see about cranking this up and see if we can inject some signal and see if we can locate what's going on. Right here, got a signal there. Now we're injecting the signal in, and nothing. Zilch. So let's go on the other side of the pot. That's the grid lead going to the grid cap of the tube. We'll tell you right now, tube test's fine. Tube's good. Still nothing. So I'm half scared to do this. We'll come out on the other side. I didn't put a condenser on this, or I'd go on the other side of this cap. But we're going to try to get it. We got a signal there. Now that's the grid going into the tube, the final output tube. Now just double check things. Let's do something else. We want to go back. We'll pull the grid cap off, and let's try injecting the signal right there. I don't even have to touch it. So, see how sensitive grids are? Make sure I'm getting that on tape. See? Don't even have to touch it. Alright. So we'll shut that off and shut this all off. So what does that tell us? Well, what that's saying is somewhere between this grid cap here and this point here, we're losing our signal. Something is wrong. So at this point, there's nothing else this test equipment will tell us. So what we need to do now is well, before we do anything, let's just see if the radio even works. So what we can do is we can bypass a lot of this. We can hook a lead right here and come around. And boy, if I'm moving things around fast, I'm sorry. I'm going to come around the grid cap and see if we got anything. And we don't. Huh. That funny thing was, it was working earlier. That's interesting. Well, we did have a signal. Now we don't have a signal, which could mean something else. If I touch the grid cap, I am picking up some noise.
Learned one. Our Fox football scout, Chris Landry.
That's interesting. I turn the volume control all the way to one end and I lose it.
Radio, they immediately do something really cool. Like Colin Kaepernick, who I was just burying, and he gets a touchdown pass for the 49ers as they have tied the Saints at 7. What do you make of Kaepernick? Now, it's easy to criticize him and say, hey, he's more
Tongue
worried about
controllers.
selling mighty wings than he is.
So we'll shut that off. The radio is working. I thought for a minute there I lost one of the tubes, but no. Well, that also tells us something else too. When I had the volume control turned all the way to max, it just deadened out the signal. So now with the radio off, and just to make absolutely sure, come over here and shut off full power, and always be soft or safe. Soft, yeah, that makes a lot of sense. And we'll shut that off. Now we're going to hook up the meter, ohm meter, and first, let's see, just out of curiosity, just to make absolutely sure that we get something for this grid cap. Let's see if we got continuity. And we do. So the grid lead, the new one I put on, is not broken or open or anything, and it was made out of new wire. I mean, it was a roll of new coax. So what do we got? Well, let's look at this for a second. We know that we can put a signal into the grid, and the audio section works. We know that we're getting a signal coming from here, and that goes down to here, and all the volume control does is it adjusts the resistance between this and the grid cap. But we're not getting a signal here. So that pretty much leads us back to something going on with this volume control. Now if you remember, this is one I replaced, and it was working. So if it was working, let's do this. Let's see if we got resistance across the entire volume control. That goes to one side, and this is on the other side. Wow, ain't that interesting? Oh, I turned the thing. Huh. So if I go one direction here, that's all I'm doing is turning the volume. I go to one end, I get pretty much what is across that volume control. It's supposed to be a 2 meg, but I know that it only read about this originally. But if I start turning it down to the other direction, now remember, I'm not attached to the center. It goes to down around 200 ohms. I'm attached across the entire distance across the volume control. Here's the old one that was damaged. I'm attached across here. I'm not attached to the center wiper, but it acts like a center wiper. The volume control may be actually operating, but we're losing the signal to somewhere. My suspicion was, when I was doing this, checks before, was it's going to ground. Now, there's nothing wrong with the volume control. Yeah, I could sit here and not say this and just fix the stupid thing off camera and come back to you in another video and say, hey, see, now it's working just fine. No, it's my mistake. When I replaced this, what I did was I replaced the center section, just this piece. Yeah, I'm sitting here showing this, not on the camera. I just replaced this piece, is what I did. Well, it came out of a part that, you know, had a smaller knob, shaft, because it was a single shaft. So I had to file out the insides of this. Now, the first thing everybody's probably thinking at this moment, I got some shavings in there and that's what's shorting out. No, that ain't what happened. I cleaned it up good. But I was so engrossed in doing that and getting that shaft to fix that I didn't realize and didn't really pay attention how the volume or how that potentiometer was designed. It's designed like this one, and I've already tore this one up because I was going to try to use it, but actually the center connection was connected right to here. In other words, the wiper itself goes to ground and the two ends don't. Now, some pots are designed where one end will actually be attached to the threaded connection or some point on here and go to ground. But these, what they came out of, they were designed to the center, the wiper, go to ground. And I didn't really pay that close attention to that, and that's why it's doing what it's doing. Now, I could probably rewire this to make use of that, and I might try that first, but I'm going to try to put this one in. I've got it working by just putting some lead pencil lead across it. It may stand up, it may not. If not, I've got a 2 meg pot that doesn't have a tap off, but what I can do is I could put that in there and redesign the circuit a little bit. Find me a pointer here, and I'm going every which way. Okay, the way this is designed, it taps off at 500K, goes down through a capacitor and resistor. What this is just a kind of a bypass filter to cut out some frequencies, so when you're using the phono jack. It really has nothing to do with the radio, and I could actually just leave it out if I really wanted to. But if I ever wanted to hook up a phono jack to it for whatever reasons, or if I wanted to leave this in the circuit and I only had a non-tapped potentiometer, what I could do is bring this lead up, take it through 1.5 megs here, resistor, and tap into here. And that would be good enough, but to even make it even better, I could drop off a secondary tap off of that and make a full, after the 1.5 megs, drop another tap off of 500K. Because see, you got a 500K and a 27K with the capacitor in parallel here, and then you got 1.5 megs above it, and that would actually reduplicate this circuit. And I may have enough room in here, maybe attach something in this area here, or down towards the bottom down here. I haven't decided, but we're going to try that one I fixed and see if it'll stand up. If it stands up, then we're good. So anyway, that's where we're at. We had a troubleshooting problem, and honestly, it is my mistake. I wasn't thinking, and you know, we all make mistakes. I didn't create this just to have a teaching lesson. This was an honest error. But the beauty of it is the radio, it needs alignment. I did a little bit by ear after I got it to play, but the radio is playing actually, and it's not its fault that some dummy was working on it and grounded out the signal to ground for the audio. So we're running long on this one again. I talk too much. Thanks for your comments. You guys have been really generous and kind in your comments. I really do appreciate it. And thanks for, I've got a couple more new subscribers. I thank you guys for jumping aboard. And next video I'll go ahead and have this fixed. I'll show you what I decided to do with it, whether I decided to put in this part back in, make up that other circuitry, or try to rewire this. I'll probably try rewiring this and seeing if I can make use of the way it works and is intended to work the way it's working. So anyway, until next time, thank you, and take care, and I'll see you on the next video.